absorbed. And air, of course, contains oxygen. So when white light, regular sunlight, shines on that material, the light reflects off the oxygen inside, and that returns the full white light spectrum. Now, glacial ice, as I mentioned, is formed from compressed snow. And during that compression process, almost all of the air is squeezed out of the ice. So we end up with an ice that's quite dense, far denser per unit volume than regular ice. And this combination of the density and lack of air give glacial ice the unique ability to absorb almost the full white light spectrum, with the exception of blue light. So it's the blue light that's returned to the viewer. Okay, now the second question was asked is, why is the glacier dirty? Why is there all this dirt on top of the glacier? And if you look around, you'll even see some piles of dirt on the glacier where it looks like perhaps a giant dumped his vacuum cleaner back. We call these, there's a couple of them to the right here, called dirt cones. You can see them at the on the right at the front of the Ice Explorer. There's one, but they're throughout the glacier. Dirt is naturally occurring in snow. Every snowflake begins with a contaminant that's in the atmosphere. This is sometimes inorganic materials such as dirt and dust, as well as organic materials such as soot and ash from forest fires and volcanoes, small seeds, and pollen. This material is floating in the air, and when water attaches to it and that freezes, that becomes a snowflake. So every snowflake has a contaminant in it. Now, as I mentioned, glacial ice is formed from compressed snow. So it only makes sense that when glacial ice melts, these contaminants in the snow from which the ice is formed are released. And that's why you're seeing a dirty glacier today, because this glacier is under an extremely high melt today. Now the water that's flowing from the glacier is actually filtered by the ice. So this water is about as pure as water can be. And many of our visitors drink it. And I think I noticed a few people filling water bottles up. Am I correct? Okay. Now, did your shuttle driver tell you the secret about the glacial water? Yes? You were told this? No? Okay. Well, okay, perhaps I should have told you before letting you out. It's too bad about that microphone acting up right at that key moment. Some of you might not like this. It only works if you're over 30. But if you're over 30 and you drink the right amount of the water, and it has to be the right amount, you'll wake up the next day 10 years younger. Okay? Guaranteed. Now, I guaranteed. I used to tell people what the right amount is, but I'm from Philadelphia, and I had a group of, the whole bus was full of fellow Americans like yourselves. And so I thought, you know, I could be honest with these people and tell them the right amount. But they claimed that it didn't work, and they tried to sue me for it. Okay, it took a couple of years to get this thing worked out. Now, I know the problem was that they simply didn't know how to convert liters into American gallons. See, we used to have imperial gallons here in the United States. So that's how I got out of that thing. But can you imagine them doing that to a fellow American, especially American living in Canada from Philadelphia? Like, that's about as bad as it gets. Okay, down below we have Lake Sunwapta, and Lake Sunwapta receives all the water from this glacier, the Athabasca Glacier that we were just on, and there's two other smaller glaciers in the area as well. Now, folks heading up to Jasper follow the Sunwapta River almost all the way to Jasper. But near Jasper, that river flows into the Athabasca River, which water flows into the Mackenzie River, and then the Mackenzie River flows into the Arctic Ocean. Behind us, from the other side of the ice field, we have water flowing into the Columbia River. The Columbia River heads southwest, and the water flows into the United States, the states of Washington and Oregon. And then the water flows into the Pacific Ocean. Now, finally, we have water flowing from a glacier just on the other side of this mountain to our right. This is called Mount Athabasca. In the next mountain valley over, we have the Saskatchewan Glacier, which feeds the Saskatchewan River, which initially flows south, and then at a place called Saskatchewan River Crossing, the river turns east. And the water flows across Canada's prairie provinces of Alberta, Saskatchewan, and Manitoba, and then into Hudson's Bay, into the Arctic Ocean, into the Atlantic Ocean. If you take a look behind us and to our left, this mountain is called Mount Snowdome. And we're so close to it, you can't see the snow over top of the Mount Snowdome. But when you're in the shuttle bus, you'll be able to see the Dome Glacier that's on top of Mount Snowdome. Mount Snowdome is covered over the top by the Columbia ice field. It's also the tallest point of the Columbia ice field. And because it's the high point in the central region, the ice that forms up there flows downhill, and it enters these melt streams that I was talking about that connect to each of the three independent oceans that surround the continent of North America. And we call this a triple